the future's calling. Maths and mind colliding. Daily dose of power. AI's here. Siya. Kubeka, let's learn the new way. Siyahamba phezulu. Daily dose of power. AI's here. Siya. Kubeka, let's learn the new way. Siyahamba phezulu.
Welcome, guys. Welcome to another lesson of the Daily Dose of Mathematics. Today we're doing 3.2 and then we're going to be focusing on 3.2.1 of the June 2026 Limpopo question paper. Limpopo, what is our question for today?
A rubber ball drops from a height of 3 meters, loses 20% of its previous height on each rebound. Calculate the height the ball will reach after the second bounce.
Okay, guys, here with this question here, it's going to be simple if we visualize it and then understand exactly what's going on. So here, let's go to our image and demonstrate exactly what's going on here. So we have a ball which is going to be dropped, and then when it reaches the floor, it bounces. Now, looking at our image here, see what do you see?
The ball bouncing down.
So the ball is from a 30 meters height. Yeah?
Yes.
So it's going to drop and then it reaches the floor. It bounced for the first time. So we're going to call that one B1. So let's just write somewhere there in the right with this one here, it's B1. That's the first bounce. Yeah?
Yes.
And then after that, it's going to reach a certain height. Remember, they say it loses 20% yeah, after each and every bounce. Yeah?
Yes.
Now, the best way to approach this question is not to look at what it loses, but what it retains, because we're interested in the height that is going to remain, guys. So if we're losing 20%,
Yes.
now we want to know what are we retaining. If we're losing 20%, we are starting with 100%, and then I say we are losing 20%. How many percent is going to remain if we're only losing 20%?
80%.
So we're going to be concentrating on the 80%. So we're going to say after each and every bounce, we're going to be remaining with 80%. After each and every bounce, we're going to be remaining with 80%. Yeah? So after P1, we go to a certain height. Yeah?
Which is
After
24.
Which is 24. Okay, now we'll show them how did you get the 24. Now the next one, we'll go to the second bounce. Let's call that one B2. That's the second bounce. Yeah? And then after that, we're going to go back again. This is going to be our remaining height. We lose 20% of 24, and then we're going to get that other height. Yeah? Now, guys, once you have an idea of how does this look like, and then remember we're dealing with percentage. Percentage, we're multiplying when we're dealing with percentage. So let's go back to the smart notes here and then demonstrate exactly how did we get this 24. So, guys, how did we get the 24? We started with 13. And I said, you can still do it. You can still say you are losing 20%, but it's going to be a long way around. So we're going to take the simplest and say, what is going to remain? If we're losing 20%, what height is going to remain? So how do we get what height is going to remain? We're going to tell them that what is going to be the remaining? Then the remaining is going to be 80% all over 100. So that's what is remaining. Yeah? So let's start with 30. And then we're going to say 30 multiplied by 8. All over 100, guys, is 0.8. Yeah? So we're going to multiply by 0.8. Or you can just type it as a fraction there on your calculator. So whichever one you're comfortable with. So what are you doing? Multiplying 0.8 or with using a fraction?
Fraction.
Okay. So I'm going to say 30 multiplied by 0.8 or 80 all over 100. What do you get?
24.
You get 24. So this is the height that is remaining after the first bounce. No? So we write that one. So we started with 30. After that, we go to 24. Yeah? Now, from there onwards, we're going to say after it reached 24, what is going to remain? Because it's still going to lose 20% of 24. Yeah? But now, we're not interested in what it loses. We're interested in what is remaining. So we're going to say again, 24 multiplied by 80 all over 100. And then what do you get as your answer?
Can you calculate?
Let's check what you get.
24.
Multiply by, you can either use 0.8 or you can use the fraction. It's up to you, whichever is simple for you.
Multiply by 80 over 100.
Yeah.
It's 96 over 5.
Yeah, say ST so that you can get the correct answer.
19,2.
So it's 19,2 meters. Yeah? So this is the answer that we're looking for. So we're going to tell them, therefore, after B2, this thing here is going to be 19,2. And then we get our 2 marks. They're going to give us the first mark for the first bounce, and then they're also going to give us a mark for the second bounce. Now, as you know, guys, we are in the daily dose of mathematics. We have our senior marker. It's a prompt that we use to check how do they mark at the marking center. So we're going to play the song that demonstrates exactly what's going on here so that you don't make mistake next time when you see it on an examination. While we play the song, we're also going to take our solution and put it on our senior marker.
Attention in the studio, let's get the sequence straight. We are talking about the ratio, the multiplier, the R. Don't calculate the draw, calculate what remains. Asambe! They say the ball is bouncing, losing 20 E's on the way. If you multiply by 20, you are throwing marks away. Subtracted from 100, what is left is what we need. 80 is kept, that's the ratio for the lead. What do you keep? Okay. That is your R. We are more now. T2 divide by T1, we taking it far.
Okay, let's listen to our senior marker.
Final grade, 2 halves. Final answer, 19, 2, text, M. CAPS marking audit. 1. Marking breakdown. Step. Working shown. Mark allocation. Justification. First bounce height 30 times, frac 80, 100, equals 24, checkmark A. Accurate identification of the common ratio, R equals 0, 80, from the contextual phrase, loses 20%, and calculation of the first term, bounce. Second bounce and final answer 24 times, frac 80, 100, equals 19, 2, checkmark CA. Consistent accuracy in applying the common ratio to find the second bounce value. 2. Corrective feedback. Your logic in image_47AC64 link to .png is completely sound and accurate. You avoided a very common geometric trap where students substitute the loss rate, 20%, instead of the retained height, 80%. Your sequential arithmetic successfully yields the correct final height. 3. CAPS and formal notation compliance. Terminology. Your arithmetic implicitly tracks a geometric decay process, R equals 0, 8, which perfectly models the problem context. Notation. While your calculations are completely correct, you missed 2 critical presentation elements required by CAPS guidelines. Units. Since the initial height is specified in meters, text M, your final answer must carry the unit label, text M. Sequence, formula structure. Writing standalone arithmetic products is fine for scratch work, but formal exam solutions should frame the problem using sequence notation or exponential decay parameters, e.g., establishing A equals 24, R equals 0, 8, and computing T_2 equals 24 times 0, 8, 2 to 1. 4. Coach's summary. What you did well. Your proportional thinking is excellent. Instantly interpreting a 20% loss as an 80% retention factor, frac 80, 100, shows highly developed quantitative reasoning under exam conditions. Area for improvement. Always state a final, clear conclusion statement that directly answers the question prompt with its associated units. For example, add a concluding line. Therefore, text, height after the second bounce, equals 19, 2, text, M. This protects you from losing easy specification marks.
See a bonga for pulling through the lesson. Hope you caught that daily dose of magic. Like the video and leave us your thoughts. Your comment counts, tell us what you need. Your comment counts, tell us what you need. Find us on TikTok and Facebook. The daily dose of mathematics is the handle. Hit our WhatsApp for the daily prompts. Get more info on 0664 682 9994. 064 682 9994. Hamba kahle. Until the next session.